My name is Karen Sorber. I'm the CEO of Micronic Technologies, and I have a passion to preserve the world's water resources. I wonder how that happened. Hello. I met this little girl in Peru on a humanitarian visit some years ago. She had no access to clean water, and it broke my heart. I was awestruck by having it in my face, how lucky I was to be from these United States. So I thought then I'd do something about it. I didn't know how. I was a consultant in government, senior advisor, etc., in the consulting world and business and federal government. How was I going to do this? Well, a year later, I re-met and married a man who had an idea about desalination. And he happened to have 21 patents in his name. So whether you think that's coincident or not, we decided to put out a shingle. So, desalination. That's where all the water is in the oceans. And if you can clean it and bring it back into fresh water, which a lot of companies are doing, then it provides good drinking water. And that's wonderful. But what's the problem with desalination? It's the brine. It's the waste that comes out of the desalination plant. So you have, either ocean water or inland water coming into a facility, going through a membrane, and on the other side you've got maybe 40–50% clean water for seawater, and then you've got the rest is brine, up to 60% waste. And in inland, it's up to 20% waste. Well, what's wrong with brine? It's hard to get rid of. The whole disposal issue. It can be hazardous waste once it comes through the ground into the filtering system and out. It can have fish kills and screw up the ecosystem. And it's not being reused if it's being disposed of. And we have a big issue in this country and around the world with not reusing water. So what's industry doing about it? Industry is approaching this with a new concept of zero liquid discharge. What comes into the plant, what goes out of it may be liquid, but what goes out of the plant is just a solid. They want to be able to get the absolute most out of the water and have it as a small amount at the end. So they want to reuse it, and then the small amount, maybe 5% or less, can be cultivated for silver, gold, nanoparticles, whatever you can get out of it. So that's what industry's doing. What's Micronic doing? Micronic Technologies has developed this product in the top right-hand corner. We've spent several $1 million in development funds. We have some left to go. It is called MicroEVAP, and it's pretty special. It actually takes that brine waste coming out of seawater or the inland water. It takes that brine and reduces it by 95%. It also is, we estimate on early lab pilots, it to be 65 to 75% cheaper. There's no scaling or crud that builds up. It's not like a traditional evaporator that has a lot of problems and you have to add a lot of chemicals. We don't have that. And it's smaller, and we've got it patented. So how does it work? MicroEVAP, we used to call it MicroDesal, is an evaporative process that's creating a tornado. So water and air comes into this device, this is one of our pilots, and hits this patented pod, which you can come over and take a look at afterwards, and it creates a tornado with the vacuum and pressures that you would see in a tornado. And what does that do? It instantly evaporates the water, creating a gazillion tiny droplets of water. And there's a very small stream that takes that nasty brine out into the brine bucket. And the rest turns into clean water through condensation. It's vaporized. It's an evaporative process. So the evaporation that takes place, the vapor comes back in through condensation as clean water. It's a tornado. a mechanically induced tornado. So how does it do? We have before and after of high TDS, high salts content, and we'll have that at our booth as well if you want to look at it. We've done as much as 235,000 parts per million of salts. EPA standards 500. We got it down to as little as 140. We've done over 300,000 in one of our other pilots. That's as bad as fracking water or worse. And so we can actually get very, very high concentrations of salts down to virtually nothing, and we can do it 95% efficient. So it's cost effective, it reduces the amount that someone has to dispose of, and it's 99% pure. So what's the market look like? Turns out India and China are really implementing a lot of regulations about zero liquid discharge. We in the United States are doing it as a policy and are trying to promote it, and a lot of companies are trying to move in that direction. We're competing with the brine concentrator market, the black circle. There's a $9 billion ZLD market, $27 billion in desalination, but we're going after brine concentrators. And how are we going to do that? We have channels to market being established as we speak. Design firms are the kind of companies that develop solutions for water and wastewater plants. They can implement our solution as part of their product offering. And there's also product companies that they may have the first 2 or 3 steps in a desalination process, and we can take it all the way out to zero. So where are we going to start? Florida. And not just because it's warm in the winter, but because they have a lot of problems there. They've lost a lot of their water access in the aquifers. There's been a huge growth of people in Florida, all the baby boomers retiring. Their growth in demand is going up 25% a year as a result. And they've got all that inland, what they call saltwater intrusion, coming in from around the state. So I've figured out a top-down market of about $17 million for small scale in Florida, taking on the small plants first. They have a total of 140, and then moving up the line, just going after their brine. We're not doing the desalination, just their brine. Did it go bad on me? How long ago? We there? All right. So these are some of our first plants that we're going to go knock on their door, and we've calculated them to be about $9 million a year. So we're going to market in Florida, but we're still in development. Let there be no mistake. We still have a lot of testing to do and engineering to do. And I've had some really productive conversations with EPA. And they're going to help us test we're going to bring one of our pilots, our new pilot that we're designing now, up here to Cincinnati, hopefully, if all the discussions continue to a signed document. You know, that's a... But I suspect it will. We're working with a really great guy, Lee Vane. He's here in the audience tonight. And then they're concerned about other things, so are we, so is the community. And these are areas that we've proven. We can get nano waste out of the water. A Virginia Tech professor just presented a paper last week about that. We can get pharmaceuticals out of the water, bacteria from leachate. You know, we can get pretty much anything out of the water. So we'll continue to do testing as necessary with EPA and other clients. Our team is lean and mean. I was a senior consultant in Washington for many years, and as I said, I married the man who was the inventor, and I've put a huge amount of my own savings into the company, and so I run it for now. He's in the bottom left-hand corner. You can tell he's got the welding helmet on. He does everything from the CAD work for three-dimensional design to fabrication and welding and whatever's necessary, Top right-hand corner, we've got Dr. Don Jordan, who has been a consultant to us for several years, is doing all the modeling of that tornado that's very difficult. He's a heat and wastewater transfer expert. Excuse me, a heat and water, I'm sorry? Fluid dynamics, sorry. Greg's, oh, and then Greg, my bottom right-hand corner, is standing with us today, and he's heard me give this pitch a few times. To Greg's right is Brianna Stollard, who's with us as well. It's wonderful. Here are some of our collaborators. At the top, we've got EPA. Comcast is interested in having us test wireless sensors. I've got a couple of universities involved. We've got our supply chain involved. And Black & Veatch is working with us now. I've got a GE award that came to us a couple of years ago. We're working on a contract with them. So what are we going to do in the next couple of years? First, we're going to get our next pilot. You saw the one. We need to get the next pilot designed and hopefully up here at EPA for testing. And then we have to refine it for production and sales in the next, say, 18 months or so. And then we'll scale it for higher volume. We've got a strategy to start sales and production in 2019, we hope, early. And then move right down the financial path of sales and implementation. This is where we are. Bottom left-hand corner is of Virginia's Wise County. And this is a shot of our facility with our pilot in the middle. So you can come take a closer look at that here in a few minutes. But I just want to end this by saying that I'm establishing relationships with nonprofits and people that are helping in developing countries, Peru, Colombia, India. And I hope that when I establish these relationships, I'll be able to get back to Peru and help that village and others that have so much trouble. Thank you very much.